A cave in Texas doesn't need a shovel anymore. It needs a snorkel. In Comal County, on a stretch of the Edwards Plateau most people will never see, a paleontologist named John Moretti pulled on a wetsuit, strapped on a dive mask, and lowered himself into a stream running through solid limestone. He wasn't hunting for water, he was hunting for bones. And the moment his face broke the surface underground, he realized he didn't have to dig for them at all. They were just there, scattered across the stream bed like someone had dropped them yesterday. Teeth, claws, shell fragments the size of dinner plates. In most caves, fossils come out slowly, one careful layer at a time, over years. Here, they came out by the handful, in an afternoon. That should have been the whole story. A lucky find, a few new bones for a museum drawer. Except some of what surfaced in that stream had no business being in Central Texas at all. Species nobody had ever pulled from this ground before. And once scientists started asking why, the answer started reaching further back than anyone expected, and further, potentially, than just the animals. The cave is called Bender's Cave, and it sits quietly on private land in Comal County, tucked into the Edwards Plateau of Central Texas. To understand why fossils were simply lying in the open here, you have to understand what this place actually is. It isn't a dry, static hollow like the caves most people picture, the ones with stalactites and gift shops. It's a water cave, a conduit carved by an underground stream that has been flowing through this limestone for a very long time. About a fifth of Texas sits on karst landscape, the kind of soft, soluble rock that rain and acidic groundwater slowly dissolve into caves, sinkholes, and springs. Cavers in this region have talked for years about certain water caves being unusually rich in fossils, almost by reputation, almost as folklore. Bender's Cave turned out to be the proof behind that reputation. Bones had been washing into it through sinkholes during ancient flooding and erosion events, then settling into the stream bed and staying there, undisturbed, for thousands of years. No collapsed ceiling sealed them in. No dry sediment buried them. The water itself became the vault. And because the cave sits on private land, none of this would have happened without a landowner willing to let a scientist swim through their backyard looking for the Ice Age. What Moretti did next barely resembles traditional paleontology. There was no grid staked into the ground, no careful trowel work, no brushing away centimeters of dirt at a time. He and a local caver named John Young simply got in the water. Between March 2023 and November 2024, the two of them made 6 separate trips into Bender's Cave, working their way through 21 distinct zones along the stream. The water depth shifted with the seasons, and the rainfall, sometimes rising, sometimes dropping. But during their sampling trips, it usually sat at only a few feet. That was enough. Wearing goggles and a snorkel, they crawled along the stream bed the way someone might search a shallow swimming pool for a dropped set of keys, except what they were finding were fragments of a vanished world. Collecting a fossil here didn't require breaking it free from rock. It meant reaching down and picking it up. Moretti would later describe it plainly. Fossils everywhere, all over the floor, in a way he hadn't seen in any other cave. That simplicity is deceptive, though. Easy collection doesn't mean easy interpretation. A traditional dig site preserves fossils inside layers of dirt and rock that scientists can read almost like pages in a book, each layer a rough marker of age. A stream bed doesn't work that way. Water moves things. It sorts them, tumbles them, strips away the very geological context that would normally tell you how old something is. So while the collecting was almost effortless, the harder work, figuring out what these bones actually meant, was only getting started. And the deeper Moretti looked at what had come up, the less this looked like a routine Ice Age assemblage. At first glance, what emerged from Bender's Cave looked like exactly what you'd expect from Ice Age Texas. A claw from a giant ground sloth, Megalonyx. Its curve unmistakable, even worn smooth by water and time. Teeth from a saber-tooth cat, the kind of fossil that instantly signals you're looking at a vanished predator, not a modern one. Bones from camelops, an extinct camel that once roamed North America in numbers that would surprise most people who've never associated camels with Texas. Mastodon remains, distant cousins of mammoths. built for browsing forests rather than grazing open plains. This is the familiar cast. Every one of these animals has turned up before in Central Texas fossil sites, going back nearly a century of paleontological work in the region. If Bender's Cave had produced only this list, it would still have been a solid, respectable find. Another data point confirming what scientists already believed about the Ice Age megafauna that once moved through this part of the state. A grazing, cooler, drier world, populated by animals built for open ground. Nothing here would have challenged a single existing assumption. It would have been added quietly to the record and left at that. But mixed in among these familiar bones were fragments that didn't belong to that story at all. Pieces that, on their own, might have seemed unremarkable. A section of shell, scraps of armor plating. It took a trained eye to recognize what they actually represented. And once Moretti did, the entire framing of the discovery changed. Because these weren't animals anyone had documented living in Central Texas before. Not once. Not in 100 years of looking. The pieces that didn't fit belonged to two animals, a giant tortoise and an armadillo relative called a pampathere. Specifically, Homicina septentrionalis, an animal built roughly the size of a modern lion. Armored, slow, and entirely unsuited to a cold, dry landscape. Neither species had ever been recorded in Central Texas before, despite the fact that scientists have been combing this region for Ice Age fossils for close to a century. That absence matters. This isn't an understudied corner of the fossil record where a first discovery might simply reflect nobody having looked hard enough yet. Central Texas paleontology is mature, extensively documented, built on decades of careful excavation. Finding something entirely new here isn't like finding it in a remote, unexplored region. It's like finding a species nobody expected in a backyard that's been searched 1,000 times. Both animals also carry a built-in clue about the world they needed to survive in. Giant tortoises and pampatheres depend on warm, humid conditions, closer to tropical than temperate. That's a serious mismatch with the version of Ice Age Central Texas that researchers have relied on for generations. A version built around a cooler, drier, grassland environment dominated by grazing animals suited to open plains. If these two species really did live here, they weren't living in that world at all. Something about the climate, the timing, or both, had to be different from what the existing model assumed. And once Moretti recognized that mismatch, the real question stopped being what these animals were and became when, exactly, they were here. Answering that question meant looking closely at the bones themselves, and what they revealed was almost as strange as the animals they belonged to. Every fossil pulled from Bender's Cave, regardless of species, shared the same physical fingerprint, polished, rounded at the edges, coated in a similar degree of rusty red mineralization, the kind of staining that builds up slowly through chemical exposure over time. That uniformity is a clue in itself. It suggests all of these bones, sloth claw, tortoise shell, mastodon fragment, pampathere armor, were swept into the cave during roughly the same window, carried in together by the same flooding or erosion events, rather than accumulating gradually across many separate episodes over thousands of years. Normally, that kind of clustering would be good news for dating. But here, it created a problem instead. Radiocarbon dating and most other precise methods depend on having the right kind of geological material surrounding a fossil, sediment layers that can be sampled and measured directly. Bender's Cave doesn't offer that. The easy collecting that made this site remarkable is the same reason it resists a clean, direct date. There is no datable layer to test, no charcoal, no stratified soil column to read like a timeline, which meant Moretti couldn't simply run a sample through a lab and get back a number the way researchers do at more conventional sites. He had to build his case a different way, piecing together indirect evidence instead of pointing to a single definitive measurement. And that indirect case started with something as basic as what these animals needed to survive. Moretti's case for an older, warmer origin starts with something almost embarrassingly simple: what these animals actually needed to live. Giant ground sloths and mastodons were forest dwellers, built for browsing dense vegetation, not grazing open plains. Giant tortoises and pampatheres needed real warmth, closer to what you'd expect from a subtropical climate than anything associated with an ice age. Put those requirements together, and you get a habitat that doesn't match the standard picture of central Texas during the last glacial period. Cool, dry grassland, dominated by grazers. If this assemblage lived here during that cold stretch, it shouldn't exist at all. But there's another window in the Ice Age record that fits far better. An interglacial, a warmer pulse inside the broader cold period. And the most likely candidate sits around 100,000 years ago. Warmer, wetter conditions during that stretch could have supported exactly this mix of forest-loving giants and heat-dependent stragglers. Animals that simply couldn't have survived the colder version of Texas most paleontologists have pictured for a century. One thing before we get to the last piece of this. If Ice Age Texas is part of the same deep story as your own bloodline, and for a lot of people watching it is, I put together a 3-volume PDF bundle over at the OriginDNA website. It walks you through reading your own raw DNA data and finding matches beyond what Ancestry or 23andMe show you. Links in the description. Stay right here though, because what comes next is the part almost nobody talks about. Habitat logic alone doesn't settle a scientific argument though. It's suggestive, not conclusive. Moretti needed something more rigorous than a hunch about warmth. He needed a way to compare Bender's Cave systematically against every other known Ice Age site in Texas. To move past habitat logic alone, Moretti ran a statistical comparison, grouping known Ice Age sites across Texas based on how similar their fossil assemblages were to one another. It's a way of letting the data sort itself rather than relying on intuition about which animals should or shouldn't belong together. When he ran Bender's Cave through that analysis, it didn't cluster with the other central Texas sites nearby, the ones built around cooler, drier, grassland-adapted animals. Instead, it grouped statistically with fossil sites near Dallas and along the Gulf Coast, locations already confirmed to date back to the last interglacial period, roughly 100,000 years ago. Those sites share the same telltale species: giant tortoises, pampatheres, ground sloths, animals that needed warmth and forest cover to survive. That match is significant precisely because it's independent of the habitat argument. It isn't just that these animals theoretically needed warmth. It's that Bender's Cave's overall fossil signature statistically resembles known warm period sites far more than it resembles its own geographic neighbors. Two separate lines of evidence, habitat requirements and statistical clustering, were now pointing in the same direction. Not proof in the way a lab-measured radiocarbon date would be proof, but a convergence, multiple independent methods landing on the same conclusion despite starting from completely different angles. For a site that couldn't be dated directly, that convergence is about as strong a case as paleontology can build. It doesn't give you a precise number, it gives you confidence in a window. And that window sat squarely on top of an assumption that had gone essentially unquestioned for 100 years of research in this exact region. For nearly a century, the working model of Central Texas during the Ice Age has been consistent. A cool, dry expanse of grassland, populated by animals built for open ground, mammoths, horses, bison, camels grazing across a landscape with little tree cover and even less warmth to spare. That model wasn't built carelessly. It came from decades of legitimate excavation, careful fieldwork, and a fossil record that, until now, kept reinforcing the same picture. Bender's Cave breaks that pattern, not by contradicting the old evidence, but by adding a layer nobody had access to before. The site doesn't erase the grassland model. It suggests that model was incomplete, missing an entire warmer chapter that simply hadn't left fossils anyone had found yet. Outside, researchers have taken note of exactly that gap. David Ledesma, an assistant professor at St. Edward's University, who studies how small animals responded to Ice Age climate shifts, wasn't involved in the study, but reviewed its implications. His read was straightforward. Even in a region as thoroughly documented as Central Texas, there are still new things to find, species nobody expected sitting quietly under everyone's assumptions. That's a notable admission from outside the original research team. It means the surprise here isn't isolated to one enthusiastic discoverer. Other specialists in the field see the same gap Moretti identified. A missing interglacial window that the fossil record simply hadn't preserved anywhere accessible, until a snorkeling paleontologist happened to look in exactly the right flooded crawl space. The research itself went through peer review and was published this year in the journal Quaternary Research, the kind of publication that doesn't hand out validation lightly. A century-old assumption doesn't collapse from one paper, but it does, for the first time, have a real crack running through it. This is where the story reaches past the animals and toward a much bigger, much more contested debate. Because reconstructing what Ice Age Texas actually looked like isn't just a question about sloths and tortoises. It's a question about the stage humans were walking onto when they first arrived in North America. Every model of how and when early humans moved through this continent depends on assumptions about the landscape they crossed. Were they moving through open grassland, easy to traverse but scarce in resources? Or through forested, warmer corridors, harder to cross quickly but richer in food and water? Bender's Cave doesn't answer that question directly. No human tool, no human bone has come out of that stream bed. That distinction matters, and it's worth being honest about it, rather than stretching the evidence further than it goes. What the site does is quietly undermine one of the fixed assumptions researchers have used to model that landscape in the first place. If Central Texas held pockets of warm, forested, resource-rich terrain far more recently and far more variably than anyone accounted for, then the maps scientists use to model early human movement across this region need revisiting too. Not because Bender's Cave found people, because it found a hole in the environmental backdrop those people would have moved through. Archaeologists studying the peopling of the Americas have run into this same problem before. From Ohio sinkholes to Texas water caves, the story of when humans arrived here can only be as accurate as the story of the world they arrived into. Get the landscape wrong, and every date built on top of it inherits that same uncertainty, whether anyone notices right away or not. For all it revealed, Bender's Cave still can't answer its own most basic question with certainty: exactly when. There's no radiocarbon date here. No measured number with a tight margin of error, the way some sites manage to produce. What exists instead is a strong, converging circumstantial case, habitat requirements, statistical clustering against known interglacial sites, and the simple fact that these species had never surfaced anywhere in Central Texas before. That's compelling. It is not the same as certainty. Moretti has been direct about that limitation rather than papering over it, calling this new window into the past rather than a settled fact. And there's a second layer of uncertainty that has nothing to do with geology at all. Bender's Cave sits on private land, and none of this research happens without a landowner willing to grant access to scientists swimming through their property. Most caves in Texas share that same arrangement, hidden away on land that belongs to someone with no obligation to let anyone in. Moretti has pointed to that fact directly, noting that partnerships between landowners and researchers are what make discoveries like this possible at all. Take that cooperation away, and an unknown number of sites like this one simply stay sealed, their fossils dissolving quietly or staying buried without ever contributing a single data point to the record. The work at Bender's Cave isn't finished either. 6 trips over roughly a year and a half explored 21 zones, but a flooded cave doesn't give up all its secrets on a fixed schedule. More trips, more zones, and potentially more species entirely absent from the current record could still be sitting in that water, waiting for someone willing to put on a snorkel and look. A century of assumptions about Ice Age Texas held up right until someone stopped digging and started swimming. No trowel, no grid, no slow excavation through layers of dirt, just a wetsuit, a snorkel, and a stream bed that had been quietly holding onto a warmer, stranger version of the past for tens of thousands of years. What came up wasn't a hoax or a stretch. The sloth claw is real. The pampathere armor is real. The statistical case tying this site to a warm interglacial window 100,000 years old is built on solid, peer-reviewed comparison, not speculation. But real evidence and a settled answer are not the same thing. There is still no precise date. There is still no human artifact pulled from that water to close the larger loop this story gestures toward. What Bender's Cave offers instead is a crack, a real one, running straight through an assumption that had gone unquestioned for 100 years of Central Texas fieldwork. And once one assumption about the landscape early Americans moved through starts cracking, it becomes harder to trust the ones sitting quietly next to it, untested, simply because nobody had a reason to doubt them yet. The stream is still running through that cave right now, in the dark, past bones nobody has found yet. Somewhere down there, the next crack in the story is probably already sitting on the bottom of the stream bed, polished, rust-colored, waiting for someone else willing to put their face in the water and look.
Thanks for watching this video. Before you go, your raw DNA data has hidden stories waiting to be unlocked. Tap the link in the description to download your ebook copy and find out what they are.